Part 2 of the gumball problem. So as you were working these things out, what I'm hoping you did was something like I did. And for me personally, I went and I worked out what that was, and I got the cubic inches of the whole space minus the cubic inches of the inner globe to figure out how many cubic inches were available in just the outer globe. A show of hands real quick. If you got 14,268 about, raise your hand please. That's half of my class. So if you did not get that, then that means you're not plugging it into your calculator correctly. So use the decimal buttons or the to the third power buttons. This is where you should be at. And that tells you that this is how much cubic inch of space you have available to put gumballs in. Then what they do on the back side of the worksheet is they ask you to guess. They say, guess, what do you think? How many gumballs could be held when the inner globe is not used? I guessed, well, 10,000 and 14,000 and 15,000. I just guessed. All three of these, it doesn't matter what you pick. What is too low to you? Well, if there's 14,000 cubic inches of space, you're putting a gumball in it. I said 10,000 was too low. I said 15,000 was too high. It turns out that my answer was way off. Like my too high number wasn't high enough. Maybe I should have put 1,000,000 there or something. I don't know. But my first guess was, if it's 14,268, I'm probably going to be able to put that many gumballs in there. That was my guess. And I was wrong. But it doesn't matter because these are just estimates. So then what you have to do is you have to figure out, okay, now how could we figure that out? If the diameter of the gumball is 1 inch, what's the radius of the gumball if the diameter is 1 inch? The radius would be half of an inch. So couldn't you figure out what the volume would be if it was half of an inch? So that's what I did. 4/3 pi r cubed. R was 1/2 of an inch. So then I turned it to a decimal, and I really wanted to get this as accurate as I could be, so I kept it at 6 decimal places. 0.523598-ish. That's the volume of one gumball. And I wanted to know how much of this volume can fit into the other volume. So I just divided. So when I was trying to figure out how I could improve my estimate, I was taking this and I was like, well, the volume of the outside sphere was this, and this is about my volume of that. What if I were to take this, plug that number in there, and do the volume of the sphere, or the outer sphere, and divide it by the volume of each individual gumball? How many of those could I fit into that volume? And that's what I'm going to work out. And you could fit a lot of gumballs in that outside piece. And so as you're going through the rest of this problems, I calculated somewhere in the neighborhood of 27,000 gumballs can fit in just the outside sphere. And when I was playing around with it, even though it doesn't ask these questions, I was like, 27,250 gumballs times 25 cents each. How much money would I make just in selling those? $6,812 at $0.25 a pop. I also wonder how much a gumball costs to put it inside there. Because this gumball machine costs us $3,000, right? Or $2,500, not counting shipping. Those are the things you want to think of as a future entrepreneur. Okay, so the rest of the calculations I'm going to let you try on your own, but I wanted to give that to you in case you were like stuck or confused.